Here we go. We're going to be dealing with compound inequalities, which are two inequalities considered together and connected by the words and or, right? And, I'll just go ahead and tell you this, is intersection, or is a union, right? Okay. So, so properties are addition property of inequalities, meaning what you do to one side, you do to the other, you're fine. And then multiplication is if you divide or multiply one side by something, you multiply the other. But you've got to make sure when you're dealing with inequalities, here's the kicker. If you multiply or divide, only multiplying and dividing across that inequality is going to flip it, right? Y'all remember that? So that, it will, that's the really only thing we got to worry about. Y'all ready? Sweet. All right. Write the set in interval notation. So it's set notation and interval notation. So I put this one on here because I wanted you to know how to write this. Okay. This is in set notation. It says for all x's such that it's between -1 and what? 0, right? So basically what you want to do is this. You want to bring down those 2 points. Interval notation looks very much like domain and range because it is. Okay, interval notation is the same as domain and range. You're talking about both coordinates being the same type, right? Ordered pairs have an x coordinate and a y coordinate, right? But interval notation is talking about a similar or same coordinate. Okay. Now, does it include -1? Yes or no? Does this inequality include -1? Well, if it doesn't include, then it gets a parentheses, right? Does it include 0? If it was to include it, it would look like this, right? Like that. Okay. Huh? Yeah, we'll do a bracket. All right. So we wanted you to be able to hear, or not hear, to see this in set notation. We got to turn around and take this and put it in what? Go from inner notation into what? It says set builder, but it's set notation. So let's kind of look at some things. All right. So basically all we're doing is creating an inequality, right? So if I put -4 and x and 2, so we know this has to happen, right? That's guaranteed. That's at a minimum, right? So because this has a bracket, it will get a line underneath. So it'd be greater than equal to, right? And then this one will not get it because of that. So this is what it will look like. Questions? So can you take it from interval notation, write it in set notation, and take set notation, write it in interval notation? Those are the first 2 things, right? Questions on that? You good? Yeah? Okay. Yeah. Why am I? Because it's compound, it's an and, it'll be between those. You don't have infinity or negative infinity on there, so you're basically looking between 2 numbers, which is telling you that it's an and because it's an intersect, right? I don't, Uh, I don't know. I mean, I've never okay. So the question was, would we pronounce that -4 and 2? Um, if I were to say it, I'd say from -4, including -4, up to 2, not including 2. That way, you're basically describing everything about this interval notation, which will allow you to easily transition over to your inequalities. So that's how I would say it. Because then you're saying, okay, you get -4 and 2, okay, does it include -4? Does it include 2? So a little bit more descriptive, and you should be okay. So I apologize if this video is just constantly beeping, but just know that I am living through it. So can you? I'll have my other charger. Yeah. Mm-hmm. 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 So what if it has, for grins and giggles, right? Something like that. All right. So this is values. What? What is this saying? Okay, so that is all values less than equal to what? So how would I notate that in interval notation? Well, what's the smallest value you can have? Negative infinity. Up to what? 5. And including 5, right? So negative in anytime you have a negative infinity or a positive infinity, anytime you're dealing with infinity, period, it will always get a parentheses. Okay? So that's how you would do that. That's a good question, though. We're going to hit that in a little bit, but probably not with the interval. So because it's algorithmically generated, it's going to check different ones, right? Okay, what does it mean for open dot? And what does it mean for closed dot? Say. Well, it's going to be a parentheses, right? Either one, beginning or end, right? And if it's closed dot, it would be a bracket beginning or what? End. Depend upon where is it at, right? So don't just say, well, it's a bracket, comma, bracket, because that's not true. Unless it's both closed dots, right? So for this one, we got -4. So right, set numbers reference and interval notation, right? Comma and -2, right? So does it include -4? No. So it doesn't include -4, but does it include -2? It does. So that would receive a bracket. Fair enough? Left to right? No. What'd you see? Oh, sorry. Yeah. Interval notation. Sorry. All right. Any questions thus far? This is going to be a little bit easier for you, okay? Of the stuff. All right. So for the following exercise, solve the inequality. Write your answers in interval notation. All right. So we're going to solve it. But what is the one thing we got to make sure we are mindful of? The multiplying or dividing across it with a what? Not adding or subtracting, multiplying or dividing, right? So we're going to go, I'm going to go -5x, right? So that's 3 less than equal to 2x plus 1. And then I'll go -1. And that's 2 less than equal to 2x, right? And then, of course, I'll divide both sides by 2. And that leaves me 1 less than x, right? Yeah? Okay, so I'm going to show you a trick on this. And I hate to say it's a trick. I flipped it, right? Well, how did I flip it? I wrote it backwards, but I want you to see something. We've got a 1 and an x, right? So I wrote it x and 1. And here's why. If you write it with a variable first, the inequality will always point in the direction that the arrow needs to go. That's the old saying, right? So just kind of be mindful of that. It's a heifer. So I'm putting 1 in x, and that's what I've done. Now, down here, the alligator's eating who? And I hate to say alligator, but come on, folks. What do you know inequalities as? Alligators. That's exactly right, because they told you alligators ate the biggest number, right? Yeah, and it stuck, right? So we're not going to reinvent the wheel. Either x is being 8, right? So therefore, when I rewrite it, x is still getting 8, right? So that's how I know that when I rewrite it, that everything is correct. Now, we know that the arrow is going to go which way? Well, which way is it pointing? To the right. So look what I'm about to do, because this is pretty cool. Or you might not think it's cool, but I think it is. Ready? Boom. Right there. I got a 1. Now, it's an open dot or closed dot? It's a closed dot. And it's going which way? To the right. What's the farthest value over to the right? Infinity. Ladies and gentlemen, 1 comma what? Thank you. X is greater than or equal to what? 1. So that's why 1 is included. Right there. Right there. Because it's in the interval notation, right? Yeah. 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 Sure will. Now, I like to graph them. But there's some people, I'll just go ahead and tell you, there's some people that can go straight from here to there. Knock yourself out. You get that a boy. I don't. Because I want to see it graphically. I'm more of a visual learner. If I can wrap my head around it visually, I'm solid. Guaranteed. So if I understand it's going to be 1 to infinity, including 1, man, it's a piece of cake right, the interval from that, right? So that's my go-between. It builds up confidence that what I'm doing is correct. I know that I know that I know. Yes? Repeat that question. Its value is greater than or equal to 1, right? So what's the biggest number x could be? What's the biggest number x could be? Infinity. So, well, it quit beeping, so that's a good thing. And still got a green light, so I don't know. Maybe it got happy or something. Any questions? Or it gave up. Just give it, huh? Inequality. It's got an equal underneath it. The alligators, just by themselves, are open. When they have an equal, that's extra, right? So it includes. It's a solid line, right? So it's solid. So, yeah. There's different ways to look at that. Okay. Solve the following inequality in interval notation. What's the first thing you're going to do that I'm going to do? What you going to do? Yeah, but I'm going to rewrite that joker like this. I hate to tell you something. But, why am I rewriting it like that? Because that's the way you need to do it, right? No. You don't need to do it like that. It's easier to see to clear your fractions if it's like that. Okay? And basically all you do is negative 1/3 times all that. It just means all that's over 3, right? So what I'll do is I'll multiply everything by 6, right? So that's going to cancel. 6 divided by 2 is what? I hate to say it's going to cancel. It's going to give me 3x, right? And then 6 divided by 3 is going to give me a what? A 2, and 2 times negative 1 is negative 2, right? And it didn't do anything over here on the other side because, you know, anything times 0 is 0. So I got 3x minus 4 plus 2x, right? Let's, uh-oh. Well, 2 won't go into 3. 3 won't go into 2, but they'll both go into 6. Why? It's a product. It's a product of the two, right? You have two factors that will always go into the product of them, guaranteed. It's like 3 and 5. 3 and 5 are both going, they won't go into each other, but they'll go into 15, right? Two won't go into 3. 3 won't go into, yeah. Oh, I'm just clearing my fraction because I hate fractions. I hate them. Oh, well, I just rewrote all of this. That's that, right? Well, this is x over 1, right? And that's over 1. So if you think about how do you multiply fractions, top to top, bottom to bottom. Yeah, yeah. No, normally people either put the x up top with it or out to the side, but it's understood that it goes with the top, right? Because if you put it in the bottom, then you have a restriction, right? We know that about restrictions, correct? Yeah. Okay. All right, so 3x and 2x is what? 5x minus 4 less than 0. And then we go plus 4. And then 5x is less than 4, divide by 5. So x is less than 4/5, right? Correct? Okay, so how am I going to write that? I'm going to go up here, right? So I'm going to go 4/5, right? X is less than 4/5, right? So what's less than 4? What's the smallest number you can have? Negative infinity, right? So you could think of it like that. Or, okay, it's an open dot, right? Which way? What's that? Do you see? Oh, hold that. So here's 4/5, here's that, and it's negative infinity to 4/5, right? And both of them get parentheses because 4/5 is not included, but infinity or positive infinity or negative infinity will always get parentheses, right? Okay, so if you think like this, there you go. I thought like you did if you went straight to that. Or if you like to graph it, and graphing's not that bad. It's good to get practicing graphing inequalities. See, x, look where the inequality pointed. To the what? To the left, right? And where did the line go? To the left. It's only if the variable comes first. Ready? All right. Snap, crackle, pop. Dang it. For the following exercise, solve the compound inequality. Express your answer in it using inequality signs, and then write your answer using intervals. Okay, y'all ready? Brad's like, no. This is? Okay, first off, it's an or, right? So I said it's not an intersection, it's a what? Union, right? Union. So like that, right? Or like that, or like what? That, right? So it'd be open set if it's like that, right? But if it's like this, and so anyway. All right, so let's solve it. So we got the first one, 2x minus 6 less than negative 11. So that's plus 6. 2x less than what? Negative 5. Switch colors, divide by 2. X is less than 5/2, right? You agree? Okay. So, and then we're going to look at this one, which is 3x plus 3 less than equals 7. So minus 3. 3x less than, let's go, that's 4. And then we'll change to this color. Divide by 3, so x is less than equal to 4/3. So, here's the question. Which one's bigger? Negative 5/2 or 4/3? Yeah. Yeah. Folks, if you're dealing with both of these being negatives or both of these being positive, you better be converting them to a decimal, right? I mean, because our brains just don't work with fractions. They just don't. Well, we kind of tend to shy away from fractions. I hate them, but I know how to deal with them, right? So, all right. So here we go. Let's draw a number line. So I got negative 5 halves, right? Right? So it'd be open. And it goes which way? That way, right? Y'all agree? Okay, good. Then I got 4/3, right? Yeah? Okay, good. And then it's going which way? Like that, right? It's closed dot? Ooh, it's closed dot. Thank you. Yeah. Okay. So they want us to inequality notation. Well, ready? X less than negative 5 halves, or X is greater than or equal to 4/3, right? That's inequalities, right? Because there's nothing I can do with it, right? Right? Okay. Yeah, I'm pretty sure. Um, okay. So let's look at this. This would be negative infinity to where? Negative 5 halves. And this would be 4/3 to where? Positive infinity, right? Now, I'm pretty sure that it's this. I'm pretty sure it's that. Yeah. I don't think it's the other one. But I'm about 99% sure of that. Right?